now. And I will, first of all, just introduce our speakers. So my name's Tara Lee. I'm a senior consultant at the Open Data Institute, and we are an affiliate of IDSP, and we are helping to run this data challenge. We have Yiu-Shing, who manages UK Power Network's Open Data Programme to help enable the net zero transition, and he works closely with data stakeholders to make UK Power Network's data more accessible, standardized, and of value to stakeholders. And for those of you who aren't familiar with the UK Power Network Open Data Portal, it features one of the UK's biggest sets of information about the electricity network. And the online portal brings together thousands of data sets from a vast range of sources to provide visibility of their network assets, where they are, what capacity they have, and how they're being used. And we also have Tom from Microsoft Planetary Computer joining us. So Tom is a software engineer, and he's a maintainer of several Python open source data analysis libraries and is a member of the Pangeo Steering Council. And for those of you unaware of Planetary Computer, it combines a multi-petabyte catalog of global environmental data with intuitive APIs, a flexible scientific environment that allows users to answer global questions about that data, and applications that put those answers in the hands of conservation stakeholders. So I will now pass over to Yiu-Shing to begin the presentations about Planetary Computer.
Not quite Planetary Computer, but UK Power Networks. Nonetheless, thank you, Tara. It's all right.
Sorry, I just mixed those up then.
It's okay. So good afternoon, everyone. I'm Yiu-Shing. I'm the I work at UK Power Networks, and I manage the Open Data Programme there. So I'll talk about our Open Data Portal. I'll talk about why we're doing it, and I'll give some examples of some flagship projects that we've completed last year. These are mainly, when I was putting together this slide deck, I was thinking, how can I encourage or inspire people taking part of this data challenge with some of the data sets we've got on the portal. So these data services that we've built are hopefully things that we'll see coming through this data challenge. So let's get that slide moving. There we go. Quick overview of who we are. UK Power Networks, we operate in the sort of bottom right-hand corner of the UK, despite being called UK Power Networks. So we serve about 8.4 million customers, which equates to about 19 million people in the UK. And we operate some pretty important parts of the country, as you can see. Very, very busy parts of the country. So electricity, you've got the transmission network, which are like the big motorways. We look after the sort of A roads and country roads, and I guess the residential roads as well. So we operate with a premise of being operating safely for our employees and people who use our network. We pride ourselves in very good reliability scores or performance in the network. Whenever there's a storm, we work hard to bring people back on. So in London, you'll notice you rarely have power cuts, hopefully, which means people don't really know who we are. Customer satisfaction, this is a new result. We came out top 3, which means we came 3rd, I'm guessing, in the Institute of Customer Service report that came out recently, which is it's worth pointing out because we are a service that you only call when you have a power cut. So you're not in the best of moods when you do contact us. And I think we've beaten the likes of, say, John Lewis. So that's worth bragging. Value for money, I think we're about £80 a year on your bill that you pay. So it's not bad. 24/7 electricity for about £80 a year. So what's the whole point behind open data? Well, the sector's undergoing massive changes. You can see here we've got things connected to our network. People expect data to be quick, fast, everything to be digitized. And I've highlighted the bottom left here. That used to be 2035. That's changed to 2030. So EVs connecting to the network, mini batteries traveling all over the network, very hard to manage, but we've got ways to manage it. So if you take anything away from this slide, open data is going to help with all this. It's just going to open up data, people get access to data, more self-service, that kind of thing. So what is open data? Data that a computer can read, essentially. So if it's on a printout map on a piece of paper in my office, not very useful, it's not open data. It's got to be suitably licensed. So I've highlighted here Creative Commons because that's what we've landed on. There's a mini debate about which one we should use, but the data's got to be licensed. So if it's stuck on a corporate website like ours historically, then it's not clear if it's called by the terms and conditions of the website or whatever. So if you're upfront about how it's licensed, it means people know how they can use it. So with our data, you guys on the call, anyone participating in the data challenge or outside of the data challenge can reuse the data, you can commercialize it, but we just ask that you attribute the source. So say you got it from us. Got here something about what is serviceable and what isn't. We operate critical national infrastructure, so naturally there are some things we won't share, and with good reason. But we explain that and we're quite transparent about it. So a little bit of a journey about where we started. So August 2021, we realized there wasn't really a metric to score ourselves with. And a lot of good managers will say you can't manage anything without statistics or some sort of measurement or metric. So we scored ourselves 45 on this open energy data maturity framework, which looks across strategy, data use, engaging your stakeholders, data management, metadata. It's quite a broad framework, and I encourage people to look that up later. Most of our data was on the corporate site, very messy, wasn't sure how it was licensed. So that was a starting point. So we launched our open data portal, and we started collecting all these retrospective data sets, things that we already published, into a place, applying a license to it and triaging it, making sure that it should be shared. And there were a lot of difficulties involved, trying to understand metadata, who in the business owns what data. But fast forward to December, just gone by, just before Christmas, we reassessed ourselves, and we got 68, which is good. And we started moving towards reacting to data requests and going forwards, looking at proactive stuff. So thinking about what our data users want to use or want to see. And then hopefully by the end of this year, we'll improve some more. So it's important to stress all the work that goes on behind the scenes. And it was really a leap of faith when we started our open data journey, but it's been good. So the next few slides are sort of flagship data services that we've provided in the past year. If you can picture an analogy of point A and point B, where the data is at point A and the user is at point B, and there's a gulf in between, these data services we build are the bridge. It gets person at point B to point A. So this dashboard it brings together, I counted 7 different data sets that would have existed in Excel spreadsheets in different formats, styles, etc., and we've put it on a page for people. So it shows, you pick a substation on our network, it shows you a 5-year forecast of maximum demand, i.e. how hard is it used and how much capacity is left. It shows you what's connected to that primary substation in terms of distributed generation. So good old wind farms, batteries, PV sites, and that kind of thing, and a sort of forecast into a few decades from now into how we think people will be using electricity. So this is a good data service that is our most popular one. And it's just an idea of what data challenge outputs could look like, perhaps. And all the underlying data is on the portal for you to use, and it's open data, so you can do whatever you want with it. Next one, this is an example of our proactive engagement in the past year. When we launched our portal, we asked people who attended, who were, I think, 200 plus, what's your top priority? What do you need our open data for? And it was planning for net zero. So we spent a lot of last year, lots of focus groups and engagement and workshops to understand what are the different use cases, and we prioritized them as well. So 30 top use cases for planning for net zero, which resulted in 153 data sets, 90 of which I think are open. Not many electrical ones, surprisingly. A lot of it was third-party data that we have no influence, or we don't own it. But this will be, I think, a good resource for those who are taking part in the data challenge. We've done the hard work for you. We've found the data sets underlying each of these use cases for net zero. We've provided links to them, and we've flagged an indication of whether the data is open or not. So this will be a good resource for the data challenge. This is a not so good news story, but nonetheless an example of a data service that we have provided most recently. Top right-hand corner, yeah, there was a threat of power cuts across the country. National Grid flagged that they might turn people off if they don't get enough generation and they need to cut demand. So you might have seen that this week with lots of people with their smart meters looking very smug, getting paid up to £10 to not use electricity. So if they didn't do that, I guess the next step would have been, I guess this would be the final straw when you start turning off primary substation. So we'd get an instruction from National Grid and we'd turn areas off. Not great, but we built this data service to help people plan. And this is a unique insight to help local authorities, those in charge, like the police, the NHS, local government, and the likes, to assist with their contingency planning if we had to switch people off, to identify, so those red dots there are postcodes, and when we've got underlying data sets to indicate how many people who are vulnerable live in those areas. So you can take that data and say, okay, there's a high density of people with oxygen machines in that area. So if the power goes off, that's where we need to make sure the local hospital is aware and the ambulance service. So nice quote down there. Hope we never have to use it. But an example of a data service, something that we'd expect from a data challenge. This one's a cool one. You just wouldn't be able to see this if it was on a spreadsheet. We've indicated to local authorities where our substations are, put noise contour rings around them, and then layered another data set which shows areas which are earmarked for housing development, usually brownfield sites next to motorways, railways, and our substations. And it's just to avoid future legal battles where we get stung with noise mitigation costs, so paying to install a wall to block noise because housing developers built a house or block of flats nearby. So we've saved about £1 million, I reckon, in last year alone. So it's great. So this is data sets that are available on our portal, quite unwieldy, not very intelligible names like the long-term development statement. But if I could summarize the data on this page, it's what you'd expect from an electricity company. We're telling you where our stuff is, what it's doing right now, electrical characteristics, location data, and future plans. So I've put in bold ones that I think are most relevant. The embedded capacity register is a good one. It shows the renewable generation that's connected to our network above 1 megawatt. And then LCT is the flip side, anything that's connected to our network, which is less than 1 megawatt, so your EV charge points and heat pumps. And then on the bottom, I flagged the local area energy planning, which is that 153 data sets that we found. Things in the future, well, right now we've started with the big stuff, the low volume assets. We're going to go to our secondary sites where we've got 116,000 sites across our region in the bottom right-hand corner that you can see. That's our service area. We'll start to look at smart meter installation volumes across our area and more technical stuff, which we don't normally report on. So it's there are data challenges. We have our own data challenge in getting that data out there and in the right format and in a correct format. So is there anything else you would like to see? And we'd love to know the reason why you want that data. You can find out what data we have. It's all very comprehensive on our open data portal. There's a section with our data roadmap where we've showed what's available, what's not available, and what's coming. And one last slide, QR codes, because we are a high-tech company. So open data portal on the left side, a license paper on LinkedIn. I don't know why we call it a license paper. It's an article on LinkedIn that I wrote about why we should all use common license, not necessarily Creative Commons or OGL or other licenses, but I think it makes sense for everyone to use one license so that you're not jumping between different terms and conditions whenever you want to use data. And then our open data principles here on the right-hand side. So like any good presentation, I'm going to tell you what I told you in the past 20 minutes. I've explained why we're doing this. Net zero, we're trying to get there, and we think open data is going to help. I've told you about our journey. It's not necessarily easy for industrial companies like UK Power Networks or Microsoft, et cetera, to open up data. There's a culture behind it, and it's not natural to open stuff up. There's a real leap of faith, but I think it's working so far. And I've explained some of and gave you a quick overview of some of our flagship data services that we've done. And those are great examples of things that I'd love to see come out of the data challenge. And then I've given you an overview of the data we've got available on the Open Data Portal. And that's it. Thank you very much.
Thank you, Yiu-Shing. And as a reminder, if you have any questions regarding anything that we're discussing today, please do put that in the Q&A and we will come to that at the end of the presentations. And now I will pass over to Tom.
Awesome, thanks. Let me share my screen here. All righty. Yeah, so going to be doing a quick overview of the planetary computer, and then happy to take questions in the Q&A at the end. So I'm also kind of halfway wearing a Pangeo hat. If you're not familiar with Pangeo, it's this group of mostly academics, some industry folks who are just really trying to do geoscience, work with geospatial data sets. Formed a few years ago now, maybe 4 years ago now, and just came out of like a lot of frustration with like tools and the data sets and the ability to do their analyses, especially on the cloud. And then from the planetary computer side, we're kind of taking a lot of those ideas from that community and others who are doing this whole cloud native geospatial thing, and trying to make it even better. So the high level goal of the planetary computer is to kind of be this geospatial data analysis platform that can support sustainability decision making. So today we're going to be diving into that geospatial data platform part of it, is looking at the data sets that we host that are available to you and some of the tools that we provide to make it easier to work with that data. High-level components of the planetary computer are the data, the APIs, and the compute, and we'll dig into each of those. Starting off with kind of the data and like how to access it. So kind of high-level conceptual stuff before we see some examples. In the Pangeo community, we like to talk about this idea of like this download model. It's this kind of workflow style way of working where there's these two distinct phases to your analysis project, research project, whatever it is. You kind of start out with a first stage where you go out and you download the data locally. So it's hosted somewhere. It could be on the cloud. It could be on an FTP server somewhere. Either way, there's a download stage where you're copying files from the source to some local storage, which could be a laptop, could be a workstation, HPC, whatever. But the important point is that there's these two distinct phases. And this works well for smaller data sets and data sets that are relatively static, not changing too often. A lot of the data sets that we're hosting are very large. So we host like 40 or 50 petabytes of data currently. And then some data sets, like we have data set from GOES, which is a geostationary weather satellite. I think it's sending down new data assets like every 10 seconds or so. So it wouldn't really be feasible to copy all of that data locally, and it'd be wasteful for everyone to have to do that. And so kind of under this cloud native geospatial model, the idea is that the data just kind of stays where it's at in Azure Blob Storage, which we'll see in a second, but more or less the data stays where it's at in Blob Storage. And then you move your compute to the data. So in this case, the data is in Azure in the West Europe region typically. So you put your compute in the West Europe region as well. And that ensures that you have the nice high bandwidth access so that you can actually load these really large data sets very quickly. And you can use scalable computing things like Dask or all of the other compute options that Azure offers. And maybe you have like a local client, like your laptop, wherever you're at, that can kind of connect into it. So you have a high bandwidth connection within Azure for these large data sets. And then if you want to, pull down an image or a small summary of the data, you can do that just fine. So that's kind of the model that we like to encourage when you're working with these types of data sets. But we feel like, if we just hosted the data, that wouldn't really be enough for our users. This is deliberately unreadable. These are just some like prefixes in Blob Storage to Sentinel-2 scenes. And it's like, if you're just given this, like, so these are files in Blob Storage, or, folders of files in Blob Storage. And if you're just given this, like, and tasked with like, find me all the Sentinel-2 scenes over Wyoming in 2022, it's like, I don't know where you'd even begin. Like, there's some dates in here, multiple dates, so you have to figure that out. You kind of have to like read the documentation, which who wants to do that? Then you have to like start opening files, which is kind of slow. You'd be parsing XML. It'd be painful. And if you wanted to, incorporate some other data set with its own naming convention and its own metadata formats, you'd be starting from scratch. So what we provide is this API for accessing, for querying the data. It's based on STAC, the Spatial Temporal Asset Catalog, which gives I think, really nice way to search spatial temporal data sets. So in this example, we're connecting to the Planetary Computer STAC API. We'll see this again later, but the basic idea is you tell it which collections you're interested in, and give it some sort of bounding box or area of interest as a GeoJSON feature. So you could give it the boundary of Wyoming, say, what date time or date range you're interested in. And you can even query on additional properties, like Sentinel provides a cloud cover percentage. So if you want to only get low cloudy items, you can go ahead and include that in your query as well. And this runs in a second or two and gives you back the items that match your query. And so this is just metadata, but you can quickly go from that metadata of like, hey, there's a Sentinel-2 scene here that matches your query to a data structure. So if you're familiar with Xarray, this is an Xarray data set or data array. So we have our 67 matching items in time, our 3 bands here. Sentinel captures a bunch of bands, but these are like red, green, and blue. And then our longitude and our latitude. So really quickly, you're able to go from a high level concept like I want satellite imagery over Wyoming to a data structure that you can actually go and analyze in just like a few lines of code. So this is what's enabled by that STAC API, is going from just a list of files in Blob Storage, which is great. It's a lot of work to get there, but it's still really hard to work with, and so that's why we have the STAC API. There are a couple other APIs for visualizing the data, which we'll see in just a sec. I want to jump over to our site now. So this, planetarycomputer.microsoft.com, if you want to go there, you can as well. The /catalog page has our all of the data sets that we host. So unlike Yiu-Shing's team, we don't create our own data sets. We're hosting data sets that come from lots of like public institutions like Landsat from USGS and NASA, European Space Agency flies the Sentinel mission. So lots of public sector data sets. We're not like creating our own data sets. There's another group at Microsoft that has like a air quality sensor stuff, but we just host their data. So lots and lots of data sets here. I don't know exactly the ECMWF real-time weather forecast data. It's global. This one might be useful for this project. But yeah, lots of data sets here. And so you've got access to the majority of these are just anonymously accessible. So you can just go in, use our STAC API anonymously, load the data anonymously. That's totally fine and freely. Some of the data sets do require an account to access. So I'll show you where that's at the end. But yeah, lots of data sets, lots of different types of data sets, all of which are somewhat geospatial. For each of our data sets, there's a bit of information here. This comes from the STAC metadata, kind of gives you a high level overview. And then we have an example notebook. Most of these are written in Python. We have an R example or two, but most of these are in Python. STAC is cross language, so you can use that from any language or just from like a browser. And then for our raster data sets, so like our kind of gridded data sets, let's say, we have this Explorer tool, which might also be helpful. So this is kind of combining the STAC API. So building up a search based on like my browser window that gets the spatial components, and then things like the time, it's going to mosaic those together, most recent first, and then you can even go in and do a whole bunch of advanced queries on all these, all the metadata that's available within the STAC items. So this is like a really good way to get a quick overview, quick understanding of the data, and kind of see some of the limitations. So I'll jump over to the UK here, and it's just it was a fun example of showing like well, somewhere here Sentinel-2 is optical, so it's got to deal with clouds, which is a little unfortunate, but you can like go in and filter cloud cover to less than 10% or whatever. There's actually some interesting structures here, which are kind of hard to see in optical. But if we jump over to this SAR product, synthetic aperture radar, now you can kind of see all these wind farms that are offshore. So it's like those really pop out because whatever, they're reflective in whatever wavelength this SAR data set is shooting out and recording. So anyway, lots and lots of data sets there for you to explore. So I encourage you to go ahead and do that if that's useful. Last thing in my last few minutes here I wanted to talk through is the kind of third component there. So we saw the data sets that we host, the API for querying those data sets, which is what the Explorer is using and which you can use. And then the last thing here is the hub. This is a way to just get some compute in Azure really easily. This is a thing that does require a Planetary Computer account, but you just got to fill out a form, and we're approving those roughly daily. And then that gets you a kind of Jupyter notebook style experience inside of Azure, which is a very easy way to get access to the data in that whole cloud native way. But you can also, if you have your own Azure subscription, do your own compute however you want it with any of Azure's compute platforms in the same region, and it'll be identical. For this example, wanted to make this example of Hurricane Florence. So I'll just play it here for the start so you can see what we're going to make. But this is coming from that satellite I mentioned earlier, GOES. That's taking pictures of, well, lots of places, but in this case, it was zoomed in on Hurricane Florence. And so, if you just had files in blob storage, this would be quite a challenge. But in this case, I'm going to skip over the first chunk here because it's kind of messy, but we don't have a data set on like, here's all the hurricanes positions, but this NCEI does. So we go ahead and grab that and basically get a track of the hurricane, which I'll plot here in a second. So they went back and cataloged it all the way from here to when it struck land. And we're going to be plotting this area here in red. So we're going to take that bounding box in latitude, longitude, and use the Planetary Computer STAC API to query for GOES CMI, so cloud moisture imagery, in that bounding box between these two timestamps that I arbitrarily chose. And we're going to also filter down to mesoscale. And you saw that runs in like a couple seconds. And then the rest of it's just like doing stuff like GOES doesn't have a green band. So you have to do things like do some band math to create a synthetic green band as a combination of the other ones, and then some stuff to make the picture pretty, like some sort of gamma correction that I don't really understand, but this other paper did it, so I copied that, and then go ahead and do the compute. So right now we're just operating on metadata. When you want to actually do the compute, you can do that and do it in parallel, and it takes about 30 seconds for this one. So all of these examples are kind of loaded into the environment when you load it up. So you can, this one's under tutorials and you can check it out. And they're also available on our site. So I think I'll leave it there with just a quick example. Quick couple of links. So planetarycomputer.microsoft.com is the place you want to go to find links to everything I talked about. Main things will be the data catalog, so you can explore what is available, see if any data sets that we host will be useful to you. And then the account request is linked from there as well. And like I said, fill out that account approval thing and you can get access to the hub and a couple of the other data sets that require an account. Otherwise, go ahead and just use the data, use the Explorer, however you want to. Go ahead and get a feel for the data sets that we host. Alrighty, thanks everyone.
Thanks, Tom. So as a reminder, if you have got any questions, please do put these into the Q&A. And in the meantime, while you're all thinking and typing out your questions that you might have for Yiu-Shing or Tom, just to flag anyone who was not able to join yesterday, we had a webinar introducing the challenge and also introducing the challenge platform that we'll be using called Rozoku, as well as some ideas on how to approach a data challenge. So we did record that session as well. What is important to note is just because you signed up to this webinar does not mean that we have your email addresses in order to send things to you. So if you haven't already done so, I would kindly ask that you pre-register. So I will put into the chat now. The email address is idspchallenge@theodi.org. So you should be able to see that in the chat. Please do flag if you don't see that. That is any inquiries you have, you can email that email address. That will come to me and one of my colleagues to pre-register for the challenge. So we will send you links to the recordings from today, from yesterday, and then the future webinar that we have next Monday, and also to let you know when registration opens on the 8th of February, if you put that in there. And we'll share the recordings, we'll share slides from the webinars as well. And also to remind you that there is one more webinar that we are holding next Monday, which will be at 4 p.m. Greenwich Mean Time, which is from one of my colleagues and is a tutorial on how to use open data if you're not familiar using open data before. So I will just put a link to that Eventbrite page as well. So I don't see any questions in the chat at the moment. I appreciate there's quite a lot of information that was shared with you today. So I'll just give it a couple more moments. But as I said, if you don't ask a question today, or don't have a chance to today, but do you want to follow up with either Yiu-Shing or Tom or myself about anything, if you send those questions through to idspchallenge@theodi.org, I will either get back to you or pass your inquiry on to Tom or to Yiu-Shing. So it looks like we don't have any questions. Are there any sort of final recommendations from you, Tom or Yiu-Shing? Is there any links?
Yeah, I forgot to mention all our data is, you can get it via API as well. It's only when I saw Tom's slides, I thought, oh gosh, I should have mentioned that. So thank you, Tom.
Yeah. I was trying to, I pulled down some of them from like the Planetary Computer hub. You get the API to the download and then load it up, and it worked out just fine. So it was great.
Great, thanks both. And yes, if at the end of this, once we have the recording ready and any slides, Tom, Yiu-Shing, if you could sort of share those with me, and I will make sure that those go out to everyone who is pre-registered. But yes, as a reminder to the audience, if you don't pre-register, I can't send you anything because I will not have your email address. I don't see any questions in the chat, so I think we can wrap up there. So thank you everyone for joining and finding a bit more about the data that's available as part of this challenge. Thank you to Tom and Yiu-Shing for your time presenting today. And wherever you are in the world, I hope you enjoy the rest of your day or your morning or your evening. Take care, everyone.
Thank you. Bye.
Thank
Bye,
you.
everyone.